All right, so check this out. In the last class, you asked me to just 5x plus 1. Some of you weren't here for that. You can roll with this. This is not that bad. Basically, what I did was I went through this whole long process to prove to you that this is equal to 3. Okay, wait. Left, right. All right. 3 times x. What was it? Plus 5, 6. 5, 6 squared minus 13 over 12. I proved to you that those were the same thing. Now, don't believe me? I'll tell you what, I'll prove it to you. You ready? Now, all right, well, I guess the first question is, Raven, would you like to know, how did you get there? And if you do, if you want to know the gross detail of how I got there, I just uploaded the video for the last class on Wednesday. It's an hour-long video, but the last 10, 15 minutes of it, maybe even 20 minutes of it, I show you how I got from here to here. And it's really the same equation. In fact, I'm going to prove it to you kind of in the slow way, but I did want to show you the power of the quadratic equation before I moved on. Yeah, it's actually called, it's a process called completing the square. And I went through in gross detail how to do this because a lot of you were confused about how to do this homework. And so I said, well, okay, this is it. It's tough, but it's pretty straightforward. Let me prove to you that this thing is actually indeed the same equation. Let me go to Desmos graphing calculator. Come on, Desmos. Sorry, 1 second. All right, so I had 3x squared plus 5x plus 1 as my graph, and if you take a look at that graph, now I'm going to make a new graph, and if my new graph, if it's going to match up exactly with the old graph, then it's the same equation. So I had, let's see, x squared. All right. So what I said was, okay, my new graph had a minus 13 over 12 in there, which is cool because look, you see the blue graph all of a sudden moved down to the same exact height as the red graph, which is the one we're trying to match up. My blue graph also had a plus 5 over 6, which is great because what it did is it pushed it to the left 5, 6 units. So this thing pushed it down, and then, oh yes, and you're right, don't forget the 3, because I mean, if you look at the blue graph, it looks like it does need to be vertically stretched in order to match that thing perfectly, and boom, that's the exact same equation. If you don't believe me, and I still would recommend maybe you should do this as an exercise. I'm not going to require it of you, but you can do it if you want. Foil this thing out. So you have 3 terms. You have an x squared plus, I think it's 5/3 x plus 25 over 36. Then multiply through in the 3. Distribute that 3 back in there. And then subtract the 13 over 12. Basically, expand this thing right here, and you'll get exactly this thing right here. Are we cool with that? Okay. Now, here's what I would do. If you asked me here's what I would do. I would probably do this. I would say, if you were to ask me to give you the graph of, let's see, I wonder if I can do this. I don't know, I didn't try it. I'm just thinking off the top of my head. But if you were to ask me, give me this thing in vertex form. Then I would say, all right, instead of doing this complicated complete the square trick, here's what I would do. I would say, I do know about the quadratic equation. Now, what's nice about the quadratic equation is it will tell me cool things about this graph. So, for example, identify for me what A, B, and C are of this graph right here, of this equation. What is A, B, and C? Three, 5, and 1. Exactly. Good. A, B, and C. So B is 5, A is 3, and C is 1. Okay, cool. All I'm going to do is I'm going to plug, this right here is the quadratic equation. So I'm going to plug that in here, and I'm going to say, all right, well, B is 5, this is 5, A is 3. Now, I'm not going to put 43, I'm going to put times 3 and times 1. And then the 2A is times 6, or times 3. Are we cool? All I did was I took the A, B, and C that you told me, and I plugged those things in. I replaced my A, B, C, and C of my quadrant. Yeah, I just plugged and chugged it. If it's all right with you, I'm going to simplify this a little bit. I'm going to change this 2 times 3, the one on the bottom over here. I'm going to change that to a 6, if that's right with you. And then 4 times 3 times 1, I'm going to change that to a 12, and this will become 25. Is that all right with you? I didn't really do anything like super special. I just basically plugged it in. Are we cool? All right. In fact, I'm actually going to do some more math in my head. If that's all right with you, I'm going to make the 25 over 12, or 25 minus 12. I'll make that a 13. Because right, 25 minus 12 is 13. All right, that's it. What am I going to do? Oh yeah, I'm going to figure out what these numbers are. So, Raven, what's not quite? What are you talking about? Okay, I'm gonna solve this thing. I'll plug it into my calculator, and I'm gonna put -5. And I don't know how to do a plus or minus, so I'm just going to do the plus for now. Plus the square root. I don't know how to do a square root on this calculator. I guess I'll just plug it in right here. Square root of 13, close parentheses, divided by 6, equals. All right, -4.399. Does everyone agree with that? Is that what you got? You guys can try it out for yourselves. Okay, you guys actually got it wrong. I showed it to you the wrong way. Because what you did was you told the calculator -5 plus the square root of 13 over 6. Essentially, you didn't plug this into your calculator. What you plugged into your calculator was this. That's not the same thing. What you should plug into your calculator, and this is why I'm such a stickler for these things. 1 second, sorry, let me find that calculator. There we go. Oops. Okay. All right. What you should plug into your calculator is this. Wait, not that. You should plug in, I usually put a parentheses, and then I do everything in my numerator, -5 plus the square root of 13. Square root of 13. Close that parentheses and tell the calculator, I want to do that first, and then I want to divide that whole thing by 6. And the answer to that is 0.2324. Are we cool? Does that make sense? All right, so point 2. you'll also want to you'll want to wait. So you do the numerator first, then the denominator. Yeah. You for all math problems, you have to take care of everything in the numerator, and then you take care of everything in the denominator. Sorry, I'm clicking on a bunch of screens, but I just want to make sure that you guys got it. Okay, all right. And then for the other one, I would say, that would be, I'm going to put the parentheses, I'm going to do it again, -5, but this time I'm going to do the minus square root of 13, close parentheses, close that parentheses, divided by 6. And my answer that I get is -1.4342. All right. X equals -1.4342. Are they both negative? I'm sorry, I didn't see the first one if that was negative. Let's try it. -5. Oops. -5 plus the square root of 13. I'm going to put an equal sign and then divide that by 6. You're right, they're both negative. Sorry about that. Are we cool with that? That's not bad, right? All right. Here's what I would do. I would say that what you'll want to do is, this tells you, what does this tell you? This tells you where this graph crosses the 0 axis, right? And if you look at this thing, and it makes it really cool, because not using this one, but going from straight off of this equation right here, look at where it crosses the x-axis at -0.232 and -1.434. Are we cool? So I would venture to say that if I know the x-intercepts at these 2 points, then I could figure out where the x-coordinate of the vertex is. And this is just old school stuff. This is nothing new that we're doing. This is the same thing. What I would do is I would take the average of those two numbers. So then I would say, wait, where's my calculator? It's down here somewhere. All right, here we go. This number plus -1.43425. What does that equal to? And then divide that by 2, right? Because you add them together and you divide it by 2. And you get 0.833329 0.60 or 0603. 0.833, -0.833. And if you look at the x-coordinate, look at what the x-coordinate of this vertex is, right here. Isn't that cool? All right, let me show you something else that's cool, okay? Say I wanted to get the y-coordinate of it. Well, what I would do is I would take my x-coordinate and I would plug it in to my equation and I would figure out what the y value is. So what you want from me is you want to do, all right, -8.33. Okay, let's do this. 3 times, parentheses, -0.833, close parentheses, squared. Okay, that's the 3x squared, plus 5 times, parentheses, -0.833, plus 1. All I did was I took 0.833 and I replaced it in for the x, or -0.833, replaced it in for the x, and plugged it into my original equation. And let's see what I get. I get -1.083333, whatever, right? But what's cool about it is, look, that's that number right there, -1.0833. All right, so I don't know if this was the easier way of doing it, but essentially, you can use the quadratic equation to give you the vertex form. Mind you, it won't necessarily be as nice numbers. You'll have to work with a lot of decimals, and it's just going to kind of be a pain, but it's pretty cool. I don't know if you see that as cool. I think it's cool. All right. So really, what it is I'm showing you that we're going about doing the same thing, just in different lights, in different ways. All right. Let's continue on with our lesson. So I showed you how to do this. All right. That's reducing the. This is reducing the fractions to be something a little bit nicer. And then look what they did for us over here is in problem set 1 of quadratics 8. What they did was they solved for us the quadratic equation. They proved to us where it comes from. Now, I already went through this with you. I spent the whole hour doing this with you. I thought it was the coolest thing in the world. But I'll go over with you what they did. Why did they multiply by 4a on everything? To be honest with you, I have no idea. I don't know why they did it this way. To be honest with you, it doesn't look like it motivates for me for any reason why they would do that. I think that my proof was better. The one where I went through it with you. This was like a week ago, maybe last week Friday. So I'm going to skip their proof. There's similar steps, but I'm going to skip their proof completely. All right, and then let's see. Problem set 1, all they're asking you to do is find for me the A, B, and C, or identify A, B, and C. So A is 2, B is 4, and C is -3. Okay, that's pretty straightforward. And then you just plug it into the quadratic equation. I'll tell you what, here's what I'm going to do today. I'm going to show you guys how to plug it into your calculators correctly. Got it? And we'll do it on a calculator that you'll probably be using a lot of, which is the Google calculator, or really just Google. All right, give me a second. Computer's thinking about what it wants to do. Let me know if the audio ever cuts out, by the way. All right, so here we go here. Click here. I'm going to change the size of this thing. There we go. All right. So I'm going to click here. And what I want to do is I want to plug in this thing into my quadratic equation. All right. That would be -4 plus the square root. I think square root for Google is just SQRT of 4 squared minus 4 times 2 times -3, all divided by 2 times 2. All I did was I just plugged this into -b plus or minus, or in this case I only used the plus. -b plus square root of b squared minus 4, or minus 4 times a times c. Maybe I should put a parentheses around this thing right here. Divided by 2 times a, and in this case a was 2. So if I press enter, will I get the right answer? That's my question for you. Yes, no, or you're trying to trick us, Mr. Balde? And the answer is, I was trying to trick you. I was messing with you completely. Because, the reason why I tried to trick you is because, look, it's the same problem again. What you did was you didn't put a parentheses around the entire numerator. Everything in the numerator is all of this stuff over here. What you did was you excluded the -4 out of this thing right here, this divide by 2 times 2. And actually, you know what? Your denominator is wrong too. You want to put everything over there in the denominator. It's the same problem we've been running into. Here, let me show you what the problem is that we made, what the mistake we made. All right. Essentially, here's what's going on. All right. I think I have an extra parentheses in there. There we go. Get rid of that. This is what I thought I plugged into my calculator. I'm sorry, oops, it's not 4 to the 4th power, it would be 4 squared. Right? If I look over here, this is what I thought I plugged in. Negative 4 plus the square root of 4 squared minus 4ac divided by 2a. Okay? And I didn't put any parentheses in there. I just did this. Does that make sense? Here's what I actually did put in. When I thought I plugged that into my calculator exactly like this, and so today's lesson is going to be about, not about how to use the quadratic equation, because it's really just plug and chug, but probably the more simple, or maybe it's not simple because it's still complicated, but the more common mistake is plugging the dang thing into your calculator. How sad it is that you guys are able to do all the math and then you, at the very end, you get the answer wrong because you didn't plug it into the calculator correctly. See here, I'll show you how I know that this problem is wrong. The answer they gave you was 2.3245532, whatever. 2.32. Just remember that. 2.32. If I go to Desmos and I graph this thing, and what was the original equation? It was 2x squared plus 4x minus 3. All right. 2x squared plus 4x minus 3. Look at where it crosses the x-axis. It crosses at negative 2.225 and also at 0.225. So it doesn't cross anywhere at 2.234. Does that make sense? So I mean, if you look at the graph, the quadratic equation is supposed to tell us where this thing crosses the x-axis. And when we plugged into our calculator, it told us, oh, it crosses over here at 2.2 or 324, like somewhere around here. And you can see that it doesn't cross there. So you must have plugged it into your calculator wrong. Let me show you exactly what you did plug in. You thought you plugged in this. What you did in fact plug in was this. Okay, wait, let me give you more room so you can see. Let me show you exactly what you plugged in. You didn't put a parentheses around this thing over here, so you had the negative 4 over here. Your negative 4 was on the outside. You also didn't put a parentheses around the times 2, so what you had right here is this. This on the bottom will give you a totally different answer than this on the top. Does that make sense? Do you see what happened? Even though we thought we were plugging in this, and I was very careful with you, you guys actually ended up plugging in this. Now, if I put a parentheses around that entire numerator, which the stuff in the numerator should be these things over here, that will take this negative 4 and bring it to where it should be. It will calculate everything on top first. Does that make sense? And then if I take that whole number and I divide by 2 and times by 2, that won't work. So I have to put a parentheses around the denominator as well, to kind of keep them separate. Does that make more sense to you? Now, what you could do, and I'm sure that this is what some of you are doing, is you could calculate each step one at a time. You know, you'll calculate, well, what's 4 squared? What is 4 times 2 times negative 3? Add those together. Figure out what the square root is. Take that number, write it down, and then have a bunch of decimal places. Then add the negative 4, and then divide by 4. But I'm trying to show you how to get the answer in one fell swoop, instead of doing all of these small micro steps. The micro steps work, and they'll work perfectly for you. At this level, you don't need it to be completely super accurate. So the micro steps work. You can do each of these steps one at a time and be very careful, and that's fine. But what I'm showing you is some of you guys might be plugging in the whole thing into your calculator, thinking you're doing one thing, but you're telling the calculator wrong. So let's see what the answer is if I press enter here. 0.58. That's a problem. That's a problem. The reason why that's a problem is because it didn't correspond with what I said it should be. Oh, no, I see what the problem is. It says negative 3, and I accidentally plugged in a negative 1 over here. Let's plug in negative 3, and let's see where it crosses. Oh, awesome, at 0.58. I'm sorry. It was a small mistake. On Desmos, I graphed it wrong. Are we cool with that? Not cool that I graphed it wrong, but I mean... Alright, let's see. Then where was my other sheet? It's right here. Alright. I'll take this and put it here, and we'll take this and put it here. Alright, so let's check this out. What if I plug in, instead of a plus, I'm going to do the minus. I'm going to have the calculator do the whole thing for me one time. Negative 2.58. If I go to Desmos, negative 2.58. Awesome. Awesome. That's awesome. I'm just saying. It's awesome. So the answer is negative 2.58 and 0.58. Are we cool? And so really, once you have this down, using a different quadratic equation is really just a matter of plugging in different numbers. Like, for example, in this case, what is A, B, and C in this equation right here? What is A, B, and C? What is A, B, and C in this equation right here? I'm waiting for you guys to answer. 1, 8, and negative 1. 1, 8, and negative 1. Be careful. Yeah, all right. So all I do is I can go back to this thing right here, and it would be negative 8. Let's go with the plus first. Plus 8 squared minus 4 times A. So A was 1, and C was negative 1. All divided by 2 times 1. I'm just changing what A, B, and C are to meet my new thing right here. And the answer is 0.123. That's it. So really I mean, once I got the quadratic equation on, in fact, once I have it typed into Google, I can just really just change the numbers and I'll be happy. And if you want to check that, you can say, okay, well, let's see. 1x squared plus 8x minus 1. Look at where it crosses at 0.123. And in this case over here, yes, technically I don't need the 2 times 1. I could just put a straight up 2. But remember, the quadratic equation has the 2a on the bottom. And in this case, specifically, a was 1. So that's not always going to be the case. A could be some other number. But in this case, A was 1. So yeah, I guess you could, I mean, it would give you the same answer if you just deleted that 1 over there. See, it's still 0.123. Are we cool? All right. And really, I hate to say this, but really the rest of this stuff is just plug and chug. You plug it into the quadratic equation, you chug it out. I don't really know what else to teach you with this. Let's look at this. Let's see. All right, fine. Let's do this. This is a good way for us to kind of talk about things. All right, let's do this one. X squared minus 6x plus 8. We cool with that? X squared minus 6x plus 8. And what I'm going to look at is this thing in the quadratic equation very specifically. All right. This is the quadratic equation. Okay? What I want to look at is this very specific part of it, this part right here, the stuff inside the square root. And I want to take a look at that really closely. In fact, I'm going to give it a name, okay? I don't want you to forget this name. It's called the radicand. R-A-D-I-C-A-N-D. It's not necessary, I mean, just know that it exists. It's kind of important. You'll see why it might be important. Can you guys hear me all right? Is the audio coming through? Just making sure. All right. So the radicand is really just, you take the quadratic equation, and I'm going to delete all these time symbols just because that might confuse you. You take the quadratic equation, and you only really worry about that square root part, whatever's inside the square root. It's called the radicand. Got it? Now, for the problem specifically that we wanted to take a look at, it was x squared minus 6x plus 8. Let's take a look at what the radicand of that would be. And as Raven pointed out, A was 1, B was negative 6, and C is 8. All right, so let's do that. So, what is the radicand of that? All I got to do is figure out, well, what is... B was negative 6, so that would be square root of 36 minus 4 times 8 times 1. Let me just double check. Yeah. What's 4 times 8? 32. Okay, all right, 32. All right, so we're looking at the square root of 36 minus 32. All right, well, that's just the square root of 4, right? Which is equal to what? 2. Yeah, exactly. What is special about this radicand? About the radicand for this problem? Well, what's special about this particular problem is, well, yeah, all I do is plug and chug to figure out what the radicand is. But what I want to point out is that the answer is a nice number. The square root is a nice number. Previously, we had the number like the square root of 13. There is no square root of 13. It's just, you just leave it as the square root of 13. It's ugly. But in this one, the square root of 4 is 2. Now, watch this. Check this out. Here's what I'm going to do. Essentially, you can go back to the quadratic equation. And let's just straight up try plugging this thing into the quadratic equation. Frac, it was negative, or actually positive 6, plus or minus 2 divided by 2. I plugged it into the quadratic equation. If it's all right with you, I didn't worry about the b squared minus 4ac and take the square root of that because we already figured that out. That was plus or minus 2, right? Which we can find as that's equal to, okay, what's 6 plus 2? That's 8 divided by 2. So the answer is either 4 or the answer is 6 minus 2. So that's 4 divided by 2. So that's 2. So the answer is either 4 or 2. And this straight up tells me, okay, well, obviously this graph that is 1x squared minus 6x plus 8 will cross at either, plus 8, will cross at either 4 or 2. Does that make sense? Okay, so apparently we got a quadratic equation that gave us nice numbers. I plugged into the quadratic equation and it gave us nice numbers. And what I mean by nice numbers is the number 4 is a lot nicer than 4.123876543, something like that. Does that make sense? And the number 2 is a nice number because it's a nice integer. But what's really cool about this is this. We could have, let's go back to our original equation. It was x squared minus 6x plus 8. What we could have done is we could have taken this equation and we could have factored it, right? You guys remember how to factor. This was like from quad 4 or something like that, quad 5, or I think it was even like quad 2. You're going to have 2 parentheses, you're going to have an x, and in this case you're going to have a, let's see, what are 2 numbers that multiply out to be positive 8 but add up to be negative 6? That would be negative 4 and negative 2. Right? If you don't believe me, FOIL this thing and you'll find that it's the same. Actually, you know what I should do is I should just put a straight up equal sign because that's what it is. It's equals. Oh. Right. That's the same thing. So we could have solved this problem using factoring. We didn't have to use the straight up quadratic equation. We could have used factoring. And then we said, okay, well, if this is equal to 0, then either x is equal to 4 or x is equal to 2, which we saw in Desmos, x is equal to 4 and 2. So, like I said, remember, I compared, in fact, I was walking in Walmart yesterday, and for 84 cents, I can buy a fly swatter. I think I'm going to go get one, just because it would be a great tool to use to show you. Factoring is a nice, quick way of solving the problem. It's not always doable. The quadratic equation will always work. Even if it's something easy like factoring, the quadratic equation will work on it. Does that make sense? And what is a tall tail sign that, also the second symbol on the left tells us that the other symbol, oh yeah. The minus 4, you would translate that as x equals to 4. Because you would say x minus 4 equals 0 or x minus 2 equals 0. And then you would say, oh, so x is equal to 4 or x is equal to 2. Right. But what I'm saying is, the tall tale sign to know whether or not you could have gone back and factored it instead of used the straight up quadratic equation is if the radicand comes out with a nice number. And in this case, the radicand did. It was 2. So we know that it would be possible to solve that using the quadratic equation. Does that make sense? So if you're given a problem, x squared minus 6x plus 8, you don't always have to use the quadratic equation to solve it. You could factor it and solve it. Factoring is easier. But factoring doesn't always work. So you'll have to use complete the square or quadratic equation to solve it if factoring doesn't work. And the way you know whether or not factoring would have worked or not is you look at the radicand. And if the radicand is a nice number, then factoring will work. If the radicand is an ugly number, like instead of the square root of 4, you're left with the square root of 35, then you know that, I couldn't have factored it, even if I tried. I could have gone through and factored it, and it wouldn't have worked. I would have never figured out the right answer. Does that make sense? So here's the same equation in 3 different ways. I have x squared minus 6x plus 8. I have x minus 4, x minus 2. And I also have this in vertex form. And you can obviously see that that's in vertex form because, look, this thing is moved down 1 and to the right 3. But if you go to Desmos, this parabola is moved down 1 and to the right 3. So these are 3 different forms of the same thing. This is like the same person wearing 3 different outfits. It's still the same thing, it just looks a little different. And there's advantages and disadvantages to each of them. One advantage of looking at it in factored form is you're able to see where the zeros of the function are real quickly. You can immediately look at that and say, the zeros of that function are at 4 and 2. Does that make sense? Now, what is the advantage of having something in standard form? And remember, I told you that the standard form, I don't know why it's necessarily called the standard form, but it's probably, I hate to say it, the most useless of the forms. There is one use for it, and that's to figure out what the y-intercept is. Because when you want to figure out the y-intercept, you plug in x equals 0. If I have x equals 0 here and an x equals 0 here, that would be negative 4 times negative 2. And I guess I could multiply that out easily, and negative 4 times negative 2 is positive 8. But with the standard form, I can immediately look at this and say, oh, it's just that last number. Because if I plug x equals 0 here and x equals 0 here, that pretty much just eliminates these things, and I have x equals 8. I have to do a few more calculations over here, but really the standard form, I think, is the only good thing about it is it gives you the y-intercept real quickly. And also, here's the other good thing about the standard form, is it's set up, is we have a special equation that uses the standard form called the quadratic equation. So if I know the problem in standard form, then I can plug it into the quadratic equation and I would be happy. Are we cool? Now, if I wanted to find the vertex of a function, the best one to use would obviously be the vertex form, hence the name. Vertex form, you want to find the vertex. In this case, you know that the vertex exists at the coordinates 3, negative 1. Positive 3, negative 1. Right? Because this parabola is moved to the right 3 units and it's moved down 1 unit. So if you, in your head, you visualize, you have a parabola, you're going to move it to the right 3 units, so that's 1, 2, 3. Its x-coordinate is going to be positive 3. And you move that thing down 1 unit, its y-coordinate is going to be negative 1. We cool with that? Now, whether or not a parabola opens up or down, you know, like it's that number out in front, and that would govern whether it opens up or down. Really, to be honest with you, all of these are just as good. Because the thing that governs whether it moves up or down, it points up or down, is a number out in front over here. We usually call that the A term. If that's positive, it's pointing up. If it's negative, it points down. In this case, it's positive 1, so that we didn't put anything there. But that's the same thing. We cool? But the a term exists right here as well, and then the a term would have been over here, and that would have done the same thing to all of them. So really, if you're asking which form do you want to look at if you want to know whether a parabola opens up or down, circle only one of them, I'd probably check the vertex form one, but factored form and standard form, there would be a number out here, and that would still tell me whether it opens up or down. That's the number that vertically stretches or compresses these things. That's that same number. We're going back to that thing. So you can see, I guess the whole point that I wanted to make here is you can see the advantages and disadvantages of either form. And you can see the advantages and disadvantages of how to solve a specific thing. So let's talk about this one real quick. Do I want to do that one? No, let's skip that one. Let's see. All right, let's do this one real quick. Just taking a look. All right, here we go. X squared minus 4x minus 21. Uh-oh. Give me a second. Hello?
Hi, Tosh.
Yeah.
It's Noelle. You know the forms you gave me this morning?
Yeah.
You didn't fill out the bottom.
Oh, I'm sorry. I'll come down and do that. I'm actually in class right now.
Okay, yeah.
All right.
Bye.
All right. Let's take a look at this one. X squared minus 4x minus 21. What is the a, b, and c of this equation right here? Come on, you guys. You guys can do it. In fact, somebody except Raven answer me. All right, Raven already answered me. Come on, you guys. Hurry up. Raven's like the only one participating in this class. No, don't be sorry. I need everybody else to jump in. All right. So the a, b, and c of that is 1, negative 4, and negative 21. Here's something I'm going to check. I'm going to check the radicand. I'm going to see what that number is. What was the radicand again? It was the square root of b squared minus 4ac. Oops, I think I need a bracket around here. There. Square root of b squared minus 4ac. Right, it's just the square root part of the quadratic equation. Now if I plug in my numbers, that would be, you're talking about the square root of negative 4 squared minus 4 times 1 times negative 21. And if it's all right with you, I'm going to put a parentheses around my negatives just so I don't get confused. All right, are we cool with that? All I did is I just plugged it in. All right, so that would be equal to the square root of 16. That's the same as the square root of 16 minus 4 times 21 is 84. Right? 4 times 21 is 84. Yeah. Everyone agree? Everyone agree with what I wrote down so far? I got the 16 from the negative 4 squared. Negative 4 times negative 4 is positive 16. I got the 84 from 4 times 1 times negative 21, which should give me 84. We cool? Please, someone answer besides Raven. Yes, I understand. No, we're not cool. There's a problem here. Your breath stinks. I don't like talking to you. That's why I'm not answering. All right, at least a yes. Yes from Jillian. Awesome. I don't like it when you trick us, Mr. Dalday. That's why I'm so uncomfortable with answering. All right. Well, I did trick you. This is supposed to be plus 84. Because the negative 4 here cancels, when you're multiplying out the negative 4 times 1 times negative 21, you have a negative number times a negative number giving you a positive 84. It was only a little trick. Alright. Square root of 16 plus 84, isn't that equal to the square root of 100? That's equal to 10. Hey, so the radicand is nice. That tells me, I mean, since I went through this and I went through already and I figure out what the radicand is, plugging it into the quadratic equation would be a cinch. But what I'm saying here is that tells us that instead of using the quadratic equation on this particular problem, we could have factored it. Right? And if you look right here, they factored it in the next step. X minus 7, x plus 3. Does negative 7 times 3 give me negative 21? Check. Does negative 7 plus 3 give me negative 4? Check. Okay, so this problem was actually an easy problem that we made look hard because, we used the quadratic equation or whatever. But it's not hard. It was just, we tried using the quadratic, or we tried at least doing the radicand, and we figured out, hey, wait a second, why am I doing this the hard way? I could have just gone back and do this using factoring. But what's really interesting is the quadratic equation will give you the same exact answer. In fact, I'll prove it to you. The quadratic equation is negative b, so that would be positive 4 plus or minus. I'm not going to put the square root of 4ac, or square root of b squared minus 4ac, because we already figured out that that was 10. And then divide that by 2. So it's 4 plus or minus 2. Or 4 plus or minus 10 divided by 2. Let's see. That's equal to either 7 or, what is 4 minus 10? That's negative 6. Divide that by 2. That's negative 3. The answer is either 7 or negative 3. That's what the quadratic equation told me. Now, if I look back at the factoring method, it tells me the answer is either 7 or negative 3. Hey, it's the same exact answer. Are we cool? So like I said, and I constantly refer to the quadratic equation as my grenade or bazooka, because you don't always need it, but it always works. It's not always the quickest, cleanest, most elegant way of doing things, but it always works. So some of my students decide, that means I'm going to shoot the bazooka at everything. Every single problem I come across, whether I can, I can factor it in the first place or not, I'm going to use the quadratic equation because it always works. And here's what I tell them. I say, here's the problem you're going to run into, is that the quadratic equation takes so long that you are going to be slower than everybody else. You'll get all the right answers, you'll just be slower. Does that make sense? Yes or no? I need people to make sure that you can hear me. Awesome. Raven, I'm going to give you an extra points in class somewhere. I'm going to find a quiz that you didn't do very well and give you extra points because I feel like I'm participating with you. What about you guys? Everybody else? Come on, Coco and Kay. I know you're here. Laura, can you hear me? All right, just making sure. I'm not trying to point you guys out. I just don't want you guys to be falling asleep while I'm talking to you guys. Some of my students decide, I'm going to shoot everything with the quadratic equation because it always works. And it's a lot easier than doing complete the square. And I'll tell you what, yeah, you're absolutely right. It's easier than using complete the square, even though it's doing the exact same thing as complete the square. We just did all the hard work for you up front when we proved the quadratic equation for you. But the problem is you're going to be slower. It's like trying to go into a jungle with a bazooka and kill every single thing in there. For every mosquito, you're going to pull out that bazooka and try to shoot it. You're going to run out of steam. So sometimes, all I'm saying is, sometimes it's easier to use the factoring method. Sometimes it's easy. Sometimes it only can be done using the quadratic equation method. I would learn how to do both. And the big advantage that I just taught you is learn how to identify which one you can use where. By calculating out that radicand. Like, for example, this radicand is b squared, so that's 36, minus 4 times 9, or times negative 1 times 9. So it's really 36 plus 4 times 9. So it's 36 plus 36. So really the radicand of this thing is the square root of 72. The problem is the square root of 72 is not a nice number. So I would conclude that the best way to solve this problem right here is to use the quadratic equation. I wouldn't bother factoring it. Because in my head I took a look at this thing and I said, the radicand is going to be an ugly number, the square root of 72. It's not a nice number. It's like the square root of 5 or something. Or, I mean, square root of 25 or something like that. Or the square root of 81. If it were that, then I would have gone and used the quadratic, or I would have factored it. Are we cool? And here's another heads up. There's a lot less problems. I'd imagine that there's a lot less problems that you can factor than you would have to use with the quadratic equation. Because if you can factor it, we would have had to give you the problems and set you up specifically so that they're nice numbers to deal with. But then again, you know, maybe they don't want you using the quadratic in excess, the equation in excess on your tests, so they always choose problems that are nice. So I can't necessarily say that that's true. But I'd imagine if you were to just randomly choose numbers and put it inside of this inside of a quadratic equation, then it wouldn't come out to be nice numbers that you could factor. If I just chose any 3 numbers, I probably wouldn't get something I could factor. I probably would get something I would have to use the quadratic equation on. Are we cool with this? I think this is where I'll stop. So I'll stop at about 8.5. Your brains are sore at this point, I'd imagine. But we're going to get into a deeper understanding of this quadratic equation and what you can do with it. All right. I'll talk to you guys later. That was a lot of fun for me. I hope that was interesting to you. You know what I'm going to do is Laura and Andre and Jillian and Raven. I mean, no offense, Coco and Kay, but you guys seem to really get this stuff. Is there anything in the class that I need to cover that you were having trouble with? Because I've been getting some emails. I think they're from my Algebra 2 class, but I have to double check. I've been getting some emails saying, hey, I need help with this thing right here. I don't understand how to do it. And I go through and I show you guys how to do it. But is there anything that you guys want me to cover? If not, say goodbye, and that way I'll know whether or not I can go. All right. Okay. Andre? All right. Andre's good. Okay, cool. Laura, how are you doing? Is this hard? Is it easy? All right. Laura? See you. I'm going to actually ask Laura. I'll tell you what, I'll stop the video, the archive, and then I can ask Laura.